Hello everyone. Today we are going to see a video on design thinking based classroom delivery. So here for developing and library management system, so we are going to see what are all the data structures we are going to use for developing a particular application, library management system. And here for storing, it starts with array. For storing book details or faculty details, if we know the size of the data, size of the number of books or the number of faculty or student or whatever may be the thing, we know the count of the student or the books ahead very well, we can use this array data structure because it is used for the fixed size data, right? So for storing book details, only we are going to hold 100 books, we are going to handle only 100 or 200 faculty members or students. In that case, if we know the count of the books or the students or the members in advance, we can use this array data structure. Okay, so in that case, we can use this array because it is static data structure. And next is linked list. It is of dynamic type. So for storing faculty details or student details, because new students are coming in and new faculty details are coming in, so this comes under dynamic list. So we can go with linked list. We can store these type of details in a linked list manner. And next is tag for performing any undo and redo operations. Like I have inserted a set of books now. Now I don't want that book entry into my database. So in that case, I can implement this undo redo operation. So this follows what stack data structure concept. And the next is queue data structure. This queue data structure is like for storing any demand book details, popular book details, because the popular books are say if you have only 10 books are there in a particular topic, already 10 books have taken, and new set of people are opting for that particular book. So in that case, we can hold the request in a queue, that is waiting list, and then once the book is returned back, we can provide that book to the requesting person. So in that case, for waiting list, for making waiting list, we can use queue data structure. And for graph, we can use for searching for a particular person or searching a particular book, we can use binary search tree concept. And graph, it is particularly used to represent the relationship between books, authors, or the users. To make the relationship, we can use graph data structure. So this will be explained by my students regarding this library management system. So what are all the data structures we have used? That will be carried out by my students. Thank you.
Study on library management system. So we have discussed about the post-registration system just now, right? So for what purpose we are using array data structure, linked list, and stack queue for the purpose of post-registration. The same way we are going to present a case study on library management system. Library management system and the data structures used in library management system. Okay, so this is like your design thinking based concept. Okay.
My name is Ravi. I'm making use of arrays. Yes. Here we are going to explain about library management system. In library management system, there are four data structures: linked list, stack, and tree. Array and graph will not be used in library management system. Linked list is number of works, the number of books, and the students who are eligible to list in library. And stack is in, last out. Stack is first in, last out. That undo and redo which are the book. In the book, preference program, the book.
So for stack data structure, sometimes we want to, sometimes we delete the books, right? Also the faculty or student details. Or else we have entered some detail. If you want to redo that process, we can do it with the help of stack data structure. And linked list, it is used for storing book details and student faculty details. Okay, it is of dynamic way, right? So every day we may include so many books. So for that purpose, instead of array, we are using linked list data structure.
Few follows for few customers. For example, if there are 10 books in a data structure algorithm, if you use first person, first book data structure algorithm, like that 10 books will be given and taken by first person, who given by first.
Which means you have only 10 books are there for a particular subject. Let's say data structures and algorithm. The 10 books have been dispersed. It has been distributed to the students and the faculty. And the 11th student or faculty is coming and asking for data structures algorithm book. So what we can do? We have to store the request in a queue, right? So after one, the person is returning back the book, so we have to give that book to the requested person. So for book request and all those things, we are going to store the request in a queue data structure. Okay. And next is tree.
Tree now,
Regarding that binary search tree, so everything we can perform searching. If you want to get the detail for a particular book or faculty student, you can use binary search tree algorithm for searching purpose. Thank you. That's it.